the list is. This is Tech Math 2. And we're doing
It's not showing up.
and we're doing sections 1-10 and 1-11 today. So that's probably very special. Maybe. It's hard to say. All right, there we go. Excellent. So in 1-10, we talk about linear equations. So what makes an equation linear? Well, linear means it's a straight line, right? So if it's a straight line, that's what makes it linear. There's 3. So if I had 3 equations, each of these is an equation of a line, and 3 unknowns, then I don't have a solution because they don't meet someplace in the middle. So I could have a 3-dimensional linear thing, or I could have a 2-dimensional linear thing, or a 1-dimensional linear thing. But if I throw in a square like that, then I'm no longer linear. So linear means I got a line. Okay, on page 38 and 39, we have basic properties and basic ways to solve the equation. But what we'll do is we'll just go and do it and then not worry about those rules, right? Oh, you want to know the rules? Eliminate any fractions. Excellent idea. I hate fractions. Remove all groupings. That's a good idea. Combine like terms. Isolate the unknown variable on one side. Combine like terms where possible. Divide by whatever. And number 7, check your solution. So when I'm doing something, we may skip that last step. Skip it. But check it. But checking it is important, because if you check it, then it's probably right, or it's not. If you don't check it, you don't really know. So we'll look at number 1 first, just to get warmed up. So number 1, x plus 9 is equal to 7. And what we're going to do is we're going to subtract 9 from each side. That's the isolation of the variable. And we're going to say x is equal to -2. Wow, isn't that cool? And we probably could have done that without doing any of that math, right? Now, if we take our calculator, we can go second function numeric solve. Now, you wouldn't do that on this particular problem, but you could. So, second function numeric solve. Second function numeric solve. And then you can put on one side of the equation, you can put x plus 9. X plus 9. And on the other side of the equation, you can put a 7. And then you can ask it to solve it. And wow, it says the answer is -2. Now, clearly you wouldn't use your calculator to do something that simple, but it can be done. And that means it can be done. It can be done with more complicated ones too. So everybody get the calculators to say -2? Yes? Isn't that cool? So you have $20, your calculator can say -2 also. And then you have to go to quit so you can do things again. Okay. But our calculators can solve linear things. So we move on to number 9. And we have 4x minus 6 is equal to 14. So I'm going to add 6 to both sides of the equation. So for the purpose of isolating the variable on one side. And then I'm going to say, I'm going to divide both sides by 5. No, I'm not. I'm going to divide both sides by 4. And I'm going to say x is equal to 5. And again, I'm going to go back to my calculator, second function, numeric solve, and I have 4 times x minus 6, and on the other side of the equation, I have a 14. I ask it to solve the problem. Wow, 5. Smart calculator. Okay. Questions about that? Not really. 24. 24? Really? So when was the last time you solved problems like this? Or when was the first time you did it? 8th grade? Yeah, probably 8th grade was the first time. Why? Unless your mommy and daddy made you do it sooner, like kindergarten. Plus 7 is equal to 6. All right, so the rules say we want to combine things. So I got 8y minus 12 minus 3y minus 7 equals 6. And then I'm going to bring the y's together. 5y minus 19 is equal to 6. I'm going to add 19 to both sides of the equation. And I'm going to have 5y is equal to 25. Divide by 5. I know I want to divide by 5 sometime. And y is equal to 5 again.
You mind scrolling back up? Oh, okay. Never mind.
4 times 2 is 8. That time, minus, right, exactly. And again, we could put the problem in our calculator directly. Second function, numeric solve, 4 times parentheses 2x, but we could make it a y. If I hit the button that gives me the x price, I can get a y. Minus 3, close parentheses, minus, close parentheses. I'm using the minus key, not the, oh, bummer. It's not going to work. Times y plus 7, close parentheses, equals 6. And I have to go back because I put in a 2y instead of a 2 times y. So I'll go back and do an insert times. Okay, there we go. And my calculator says, oh, y is equal to 5 again. Oh, wow. So if I put in my calculator, what I did the first time is I put in 2y. Then the calculator assumes that that's the variable. You have to put in 2 times y in order for the calculator to know that that's what you want. Okay? Where was I? 36. All right, so 36 is going to be the get rid of the fraction problem. Plus 1/6 equals 2 over 3y plus 1 over 9. All right, so I look at that and I say, well, what's my common denominator? 18. All right, so I'm going to multiply everything by 18. 9y plus 3 is equal to 12y plus 2. Okay, we're going to subtract 2. And we're going to subtract 9y, all at the same time. Why am I subtracting 2 for? Subtract 3. Much better. All right, so I got 0 and now I've got 0 and 0. Oh, I was doing exactly what I wanted to do. All right, go back to what I was doing, paying attention to what I was doing. Okay, so that's 0. I have 1 on this side. 1 is equal to 3y. So y is going to be 1/3. All right, that seems reasonable. So now we'll go back and check our work. Is 1/2 times 1/3 plus 1/6 equals 2. Is that equal to 2/3 times 1/3 plus 1/9? So that's the question. All right, so I got 1/3 on this side. 1/6 plus 1/6 is 1/3. And on this side I have 2/9 plus 1/9, which is 3/9, which is 1/3. Check. So so I checked my work. I could, if I wanted to, put it in my calculator. Okay, so I'm going to put it in my calculator and put in second function, numeric solve, and I've got a 1/2 times y plus 1/6, and then I have to do it again because I hit the clear button instead of the delete button. 1/2 times y plus 1/6 equals 2/3 times y plus 1/9. Alright, and I ask it to solve for me, and it tells me the answer is 1/3. No, it doesn't. It tells me the answer is, way to go, that was cool. That is awesome there. Alright, there we go, not better. So it told, I put it in my calculator, it told me the answer was 0.33333333333, and I said, oh yeah, that's 1/3. Sure, okay, no problem. I remember 0.333 repeating is 1/3. If I did it in math print, it might tell me it's 1/3. I'm in classic right now on my calculator, but that's one of those things. Okay, so was that 40? 40 is next. All right, so 40 is next. 5 x minus 4 divided by 6 plus x minus 2 divided by 12 minus 2x over 3, and that's an equal sign, equal 2x plus 1. And I say, well, you know, I don't like those fractions, so I'm going to get rid of them. I'm going to multiply both sides of the equation by the common denominator, which is 12. Right, so I'm going to have 10x minus 4 plus x minus 2 is equal to 8x plus 12. Much better. All right, I'm going to combine things. 10x minus 40 plus another x minus 2 is equal to 8x plus 12. Okay, I've got 11x on one side and 8x on the other side, so that when I bring the 8 over there, it's going to be negative. So I'm going to have 3x, right? 3x is equal to, I've got minus 42. It goes the other side, and I get 54. And then x is equal to, 3 goes into there 18 times. I think so, 18. Okay, now we're going to check our work. We are going to check our work. You got to be kidding me. Okay, so 5 times 18 minus 4 divided by 6 plus 18 minus 2 divided by 12 is supposed to equal 2 times 18 divided by 3 plus 1. So it's supposed to be, we'll put the question mark there. All right, well, that's 5 times 14. 5 times 14 would be 70. 70 over 6 plus 16 over 12 is supposed to equal 36 over 3 plus 1. Okay, so I've got 140 plus 16 divided by 12 is supposed to be 36 plus 3 over 3. 1 56 over 12. 39 over 3. 13 on that side. So it'd be cool if 156 divided by 12 were 13, wouldn't it? Oh, it is 13. How convenient. 13, check. So that's the way I would do that. I would, especially one that looks that way. I wouldn't skip the checking step. Now I can go and put in my calculator directly again, and I will. So we'll clear out everything that's there now. 5 times parentheses x minus 4 close parentheses divided by 6 plus parentheses x minus 2 close parentheses. They're implied, those parentheses are implied in the problem. I have to put it in my calculator, otherwise I will not get the order of operation right. 2 times x divided by 3 plus 1. So I'm asking it to solve, and I get a 9.5. I know that 9.5 is wrong, so look again, you dummies. 9.5, really? It says the answer is 9.5. Is that possible? That there are two answers? Or is it more likely that I entered it wrong? 5x, okay, I won't tell you what I did wrong, but it's extremely obvious. The first x is a 4. So I entered 4 minus 4 instead of x minus 4. Okay, try again. Now I get 5.57. Alright, so that means I had to do something else wrong. Alright, so I got 5 x minus 4 divided by 6. Oh, now I got x minus 26 instead of x minus 2 close parentheses. I fat finger that key. Divided by 12, 2x divided by 3. Alright, try it again. 18. Alright, got my calculator to tell me it was 18 after I entered it 3 times. Oh well. Couldn't happen to a nicer guy, right? Number 56. Now, you notice in the back of the book, they give you all the odd numbered answers. You notice that?
No.
That's why I always do the even ones, so that some well-meaning student won't look in the back of the book and tell me I'm wrong. Is that how that works? Something like that? 56. Okay, so I've got 1.59 10 to the minus 3 is equal to 1 over 2 pi f 1.55 10 to the minus 6. All right, well, we recognize 1 over 2 pi f times something as reactive capacitance. And so that's not going to be, this is going to be in ohms, which is a really small number, so that's going to be like nothing. So I'm going to solve the equation for pi. Pi is 3.14. There, I'm done. Oh, I'm not. Solve each equation to 3. I solved it with 3 significant digits, and that what I did? Yeah, I mean, really. Okay, well, I suppose they want to know what f is. All right, so f is equal to 1 over 2 pi 1.59 10 to the minus 3 1.55 10 to the minus 6. All right, so if I have something that's in the form a over b is equal to c over d, which is what I have, then I can cross multiply. I can put things on the bottom here and the top there, and things on the bottom top there on the bottom there, and things on the bottom here and the top there, and things on the top here and the bottom there. So I can move those things around all I want, and that's what I did. Was that confusing enough? That's called cross multiplication. So if I have A, B, C over D, E, F is equal to H, I, J over K, L, M. I could rewrite that as A, B, C, A, B, M. A, B, M over D, E, H is H, F. F, I, J over C, K, L. Be perfectly okay. Anyway, back to that problem there. Can we do it in our head? Probably not, huh? Okay, so I've got 1. No, I don't. I have to quit my numeric solve. 1 divided by, parentheses, 2 times pi times 1.59 double E minus 3 times 1.55 double E minus 6, close parentheses, enter. And my glorious calculator says the answer is 64.5789902 times 10 to the 6th, because I'm in engineering notation in my calculator. Okay, so what's my final answer going to be? Final answer to 3 significant digits. 6.46 times 10 to the 7th would be my final answer. But it doesn't say scientific notation, right? So I could leave it in engineering notation and call it 64.6 M. I could do that, right? Or I could call it 64.6 times 10 to the 6th. I could do that too. So all 3 of those guys would be perfectly okay, notational wise, for the answer we're looking at. So I'm going to do it one more time. I'm going to go back to the original problem and do it with numeric solve. Numeric solve, and I cleared both sides of the equation. 1.59 double E minus 3 equals 1 divided by parentheses 2 times pi times, in this case I'm going to put in an X for my variable because my calculator doesn't have an F. Stupid calculator, right? Times 1.55 double E minus 6, close parentheses, enter, enter, enter. And it's going to take a little while longer. Okay, there we go. We got an answer. And the calculator says the answer is, I get back here to the bottom, 6457899.02, which is the same as what we had before. All right. Now we're in section 111, and we're going to do the same thing over again with formulas. Okay. So it looks like what we're going to do is do it with no numbers. So we're just going to go and just have something. So I can have, let me think of a good formula. Okay, phi is equal to n pi sine n theta. Okay, there we go. I just made it up. And I want to solve for n. Can I solve for n? No way. No, I can't solve for n because it's inside the sine thing and it's outside, so I won't solve for that. I will solve for theta. So I got phi over n pi, it's an n, is equal to sine n theta. And then I'm going to have, okay, that's phi. I'm going to have the arc sine of phi over n pi equal n theta. So I'm going to have theta equal arc sine of theta over n pi divided by n. There we go, done. Now, the problem is that we'll have to get to the end of the class before you'd ever see a problem like that, right? Because we haven't done sines and cosines yet, but it'll happen soon enough. Okay, so on page 47 on the bottom, we see our parallel resistance formula sitting there. On the top of page 47, we see the resistance of a wire, knowing the resistivity, the area of the wire, and the length of the wire. Oh, so that's pretty cool. In example 2, we have some triangle, some rectangle or something. Okay, so enough of that. Back to what we're doing. Number 2. So we have the circumference of a circle is pi d. Isn't that great? And we want to solve for d. Knowing that the circumference is 358 centimeters, we want to solve for d. Alright, so we're going to cross multiply again and say d, the diameter, is the circumference over pi, which is 358 divided by pi, and then we throw it in our calculator. 358 divided by pi, and I get 113.9. Solve for the letter, then substitute the data following the instructions. Okay, so I only have 3 significant digits, so I'm going to call it 114 centimeters, because I only have 3 significant digits. The calculator says 113.95449393, but I only have 3 significant digits, therefore my final answer can only have 3 significant digits. And I have to put centimeters next to it because I have some unit of length. Well, did I waste enough time doing that problem? Probably. Number 16. Okay. So the pressure the voltage. That's voltage in the primary. Voltage in the secondary is equal to turns in the primary divided by turns in the secondary. So this is a transformer problem. And we know that voltage primary is 120 volts because it tells us we are. And voltage secondary is 3,500 volts. Okay, well, that's pretty cool. And the number of turns in the secondary is 12000. And we want to find the turns in the primary. Right, so we'll do cross multiplication, say turns in the primary is equal to voltage primary turns secondary divided by voltage secondary. Okay, 120 times 1,000, 12,000 divided by 3,500.
Question.
Yeah.
You're doing the problems on exercise 1.12
Oh, I am. How come I'm doing that?
instead of 1.11. That's what I'm saying.
Hey, David, you forgot to tell me I was on the wrong page.
I didn't want
Didn't want to interrupt.
I didn't know if I was on the wrong
We're
page.
doing.
I'm flying back and forth.
Okay. So I'm back. Okay, now I'm on the right page, page 44. Don't worry about that. It's perfectly okay. I did the exact thing yesterday, so did the wrong problem. Well, we'll do that. We'll end the problem before we go on. So I'm going to get rid of these zeros and that 0, and so I got 120 squared divided by 35. 411, really? So turns primary is 411. It says 411.4, right? But I can't have a 0.4 turn, and I only have What do I have? I don't know. I turned the page. I don't know what I had. But I probably only have 2 significant digits, right? So I'm going to have a 410 turns as my final answer because I only have 2 significant digits. If I could spell turn, which I obviously can't. All right, that's better. Is that better? All right, back to the problem set we're actually doing in 11.1. Looking at number 2 again, we find that velocity is frequency times wavelength, and we want to find wavelength. So wavelength is going to be V over F. So I'm going to cross multiply and put the F on the bottom. Now, velocity is in meters per second. Frequency is in hertz, which is 1 over seconds. And when I put brackets around it, means I'm just looking at the units. And lambda is in meters, the wavelength. So frequency times lambda meters per second is frequency meters per second. So that's called dimensional analysis. And
Is that minus 1s? I can't read that.
what can't you read? That's an F. That's a D. That's a D. Victor.
No, I mean the one on the right side.
Lambda. Meters per second. Hertz, which is 1 over seconds. Lambda is in meters. So those are units of those particular guys. So don't put the units in, I'm confusing you? Okay, no problem. Number 16. Force is, I don't know what this formula is. Let's see, work times area divided by gravity. I think this guy's made up. Anyway, I'm going to solve for G. So G is equal to Y is equal to Y over F. Yeah, that's good. So I'm cross multiplying. I'm sending the G to the top. I'm sending the F to the bottom. Number 24. Oh, well, that's that one. Okay, so the volume 1, pressure 1, divided by temperature 1 is equal to volume 2, pressure 2, temperature 2. So if I have a container and it has some gas in it, then I change the pressure or the temperature or of the gas, then I'm going to get a new set of gases. So this comes from the equation PV is equal to nRT. N is the number of moles I have. R is a gas constant. So nR is equal to PV over T. So the pressure, the volume, and the temperature of a gas sample, if I perturbate any of them, then they all have to change, but because PV over T is a constant, the number of moles I have, that's an N, times a gas constant, which is a constant thing, then I have to get the same thing when I get out. The good news is that I've got one equation, 6 unknowns, so to solve for it, I have to have 5 of them given, right? But if you go to so PV equal nRT is correct, you go and let some volume out of your tires, then your pressure has to go down in order to have these guys be the same. Yeah. And the temperature is going to change too. Anyway, that's neither here nor there. That's not part of the problem. Part of the problem is what? Solve for T1. All right, so I want T1 is equal to, so I'm putting T1 on the other side of the equation, and I got P1, P2, T2 divided by V2, P2 on the other side of the equation, and now I've done what I was supposed to do, solve for T1. Number 29. Okay, so the change in length of something is going to be the coefficient of expansion times the original length times the change in temperature. And we want to solve this for T, the temperature. Okay, so change in length, alpha LT minus alpha LT naught. Change in length plus alpha LT naught is equal to alpha LT. Now I can write T is equal to change in length plus coefficient of expansion, length T naught divided by alpha L. Okay, and if I wanted to, I could change it some more and say T is equal to delta L alpha L plus T naught. I can do that. So either of those guys would be perfectly okay because I've solved for T, which is what I was supposed to do. All right, last problem, and then we can, oh, you get to hang out here. So there's no reason to not take a long time to do the problem, right? 39. Our favorite problem. I have parallel resistance. And we all know that resistance is in fact futile, so keep that in mind when you're working the problem. At least that's what the board would tell you. So resistance 1 over resistance total is 1 over resistance 1, 1 over resistance 2, 1 over resistance 3. And I want to solve for T total. All right, so T total, T. Where did T total come from? R. Resistance total equals 1 over R1 plus 1 over R2 plus 1 over R3. Are we done? Yeah, that's perfectly okay. We could decide that I'm not done yet and say, well, that's 1 over R2, R3 plus R1, R3 plus R1, R2 divided by R1, R2, R3. And then we could say, well, that's equal to R1, R2, R3 divided by R2, R3 plus R1, R3 plus R1, R2. And we could say we're done there. So either way, either place we're done. So, but when we have numbers, we're just going to put it in our calculator and have our calculator tell us what the answer is anyway. So we probably aren't gonna do that guy, but that guy's still in your book, right? So, and I could do it again. I could have 4 resistors. I got R1, R2, R3, R4 in parallel, and the parallel resistance would be R1, R2, R3, R4 divided by R2, R3, R4 plus R1, R3, R4 plus R1, R2, R4 plus R1, R2, R3, and I have the same thing all over again, so I can do that over again. But that's not something you want to remember, right? Well, yeah, you would, because it would delay the onset of Alzheimer's. So, yeah, I should remember that for forever and ever. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of you here. Wow. Randy, what happened? There's only 9 in the class. I don't know. No, must be the sun and the moon. Randy was just telling me that I never have such a day because I don't deserve it. Yeah. Maybe there's 10 in the class. Who knows?
And it's not finals day.
It's not finals day. Yeah.
That would be great.
Now, one of the things you need to remember as an electronics student is that every day you need to learn something. So if at the end of the day you didn't learn something, you can't go get on the bus and go home. You have to come find me and find out what the problem is, so we can correct it. Because it's too much to learn if you don't learn something every day. All right. Well, have fun with Mr. Kennedy.
Another question for you.
Only one?
Yeah, just one.